Today, our topic is classical mechanics of a particle. In this video, we learn three conservation theorem. Conservation theorem. 1. Conservation of linear momentum. Of linear momentum. 2. Conservation of angular momentum. 3. Conservation of total energy. Number 1. Conservation of linear momentum. At first, we consider a particle that have position vector r. R vector. R vector is the position vector of a particle from some origin O. If position vector is r, then velocity v vector equal dr dt. Linear momentum of the particle. Linear momentum of the particle P equal mv. Mass of the particle and the velocity of the particle. The product of mass and velocity of the particle is called linear momentum of the particle. Now we get P equal mv. Then the acting force on the particle F vector equal d dt of P vector equal P vector dot equal d dt of mv. M is constant, then m dv dt. Then we get force F equal m dv dt. Here dv dt equal d2 r vector by dt2. this quantity d2r vector equal dt2 equal a vector is called acceleration of the particle. If now if now acting force F vector on the particle is 0, means F vector equal 0, then F vector equal m dv dt equal 0, equal d dt of mv vector equal 0 equal dp dt the equal 0. Here we get integration dp vector equal 0 or p vector equal constant. That means if a vector equal 0 on the particle, then we get p vector equal constant. Or if the acting force on the particle is 0, then linear momentum of the particle is constant with time. That linear momentum is conserved. This is the law of conservation of linear momentum. Conservation of the linear momentum. This is the statement of the law. Now number 2, conservation of angular momentum. We know angular momentum of the particle L vector equal r cross linear momentum, means r cross p. R is the radius or position vector of the particle in a circular path. Or if a particle moving in a circular path then its linear momentum is radius of the radius vector of the particle from origin O and the linear momentum of the particle P. Their cross product is called linear momentum of the angular momentum of the particle. From the definition we get L vector equal R cross P. Now we differentiate it with respect to time. What we can get? Let's differentiate L vector. dl dt equal d dt of R cross P equal dr dt cross P vector plus R vector cross dp dt equal v vector cross this P equal mv vector plus remain term. Now this term equal 0 because v vector cross mv vector, m constant, then m into v cross v equal m into v square sine 0 equal 0 according to the rules of vector algebra or vector product. Then 0 plus r vector cross dp dt. This term r vector cross dp dt, that means time derivative of angular momentum is called the torque tau. Now what is torque? Torque is the time rate of change of angular momentum. That means dl dt equal torque. We denote it tau or n sign. Now if n equal 0, that means dl dt equal 0 or integration dl equal 0 or l equal constant. From here we get the conservation of angular momentum. Then what say conservation of angular momentum? Conservation of angular momentum theorem says that if torque on a body is 0, then angular momentum is conserved. or constant in time. That means if torque is zero, angular momentum does not change with time. Now the last conservation theorem is conservation of total energy. To know that theorem, first we should know that the work done by a force. If a force is if a force F is acting on a body and the body displaces from 1 to point 2, point 1 to point 2, and the displacement is ds, displacement is s. If the force is infinitesimal, that means if the force is df vector, df is the infinitesimal force, then displacement is ds vector. Then work done of the body, infinitesimal work done, dw equal f dot ds, or total work done, integration dw equal integration f dot ds from 1 to 2, or total work done w equal integration 1 to 2 m dv dt dot v dt. Since f equal m dv dt and ds equal v dt, from above last line we get total work done w equal point integration point 1 to 2 m dv dt dot v dt. dt cancel, or m is constant, integration 1 to 2 v dv. That means v square by 2, if we integrate it, we get v square by 2 from 1 to 2 equal in upper limit minus lower limit equal half m v2 square minus half m v1 square equal t2 minus t1. This t2 is final kinetic energy of the particle and t1 is initial kinetic energy of the particle. Then we finally get w equal difference of kinetic energy of the particle. Now also force on the particle, a vector equal minus grad function of sum scalar function v that depends on the r. This grad v equal mathematically del v del x minus del v del x plus del v del y plus del v del z. If we write this grad v in one dimension, then we can write a vector equal minus dv by dx. Now, infinitesimal work done, from this formula we get dw equal, from above we get f dot ds. Now from this formula we get dw equal value of f, that means dv by dx dot ds. This is the infinitesimal displacement, means infinitesimal distance. This is also infinitesimal distance. This distance cancelled. We get, now we finally we get dw equal minus dv. The total work done, integration dw equal minus constant integration 1 to 2 dv equal minus v 1 to 2 equal v1 minus v2. From equation 1, this is equation 2. Above we get equation 1 is this is w, and above we get equation 1 is w equal t2 minus t1. This v1 is initial potential energy, and this v2 is final potential energy. Now from these two equations we get v1 minus v2 equal t2 minus t1, or v1 plus t1 equal v2 plus t2. This equation means energy does not change always. Always energy of a particle or a body E equal constant. Or kinetic energy plus potential energy is constant. Ke plus potential energy equal constant, or total mechanical energy AV equal constant of a mechanical system. This is all. This is called conservation of energy E. Then finally we have got three conservation theorem. First, linear momentum conservation theorem. P equal constant if force equal 0, and 2, angular momentum L equal constant if torque in or tau equal 0, and at last we get kind total mechanical energy or total energy of a mechanical system or a particle or a body is constant in time.